Good morning, everyone. My name is P. Sharanteja from CSC AML, and today I'll be talking about something that affects millions of families around the world cancer, and more importantly, how technology has become one of the most important weapons we have to fight with it. Let me start with a simple but powerful fact. Every minute, 18 people are diagnosed with cancer worldwide. But due to technology, cancer survival rates are now the highest than they ever been in history. Today, I'll take you on a journey from what a cancer is to how AI and robotics and nanotech and machine learning and genomics are transforming how we diagnose and treat and even prevent it. What actually is cancer? Cancer is not only is one disease, it is 200 plus different diseases. At the biological level, normal cells divide into a controlled manner. Cancer cells ignore the rules. They multiply endlessly, form tumors, spread to other organisms, interfere with body functions. Here are the challenges. Every cancer behaves differently. When two patients with the same cancer behave differently, cancer evolves over time. This complexity makes the technology and extremely important. Without advanced tech, we cannot detect and understand or fight cancer effectively. Why traditional cancer treatment is not enough. Before technology becomes central, a diagnosis happened late. Chemotherapy killed both cancer and healthy cells. Side effects were served. Tumors could return because the change is genetically. We realized we cannot treat cancer genetically. We must treat each patient individually. We need precision and only technology can provide that. Technology enables early detection, accurate biopsies, tumor modeling, and personalized medicine and high precision surgeries. Evolution of technology in cancer care. Let us look at how far we come. In era 19th, major advances X-ray discovered tumors. In 1970s, CTs and MRI evolutionized imaging. In 19th century, 1990s, PET scanning detects metabolic activities. In 2000s, robotic cancer surgery. In 2010, the major advancement is genomic sequencing and AI medicine. In 2020, nanotechnology and digital twins. This evolution changed cancer care from slow to fast, general and personalized and imprecise and highly accurate treatment. In future, it is quantum biology. Early detection is the game changer. Early detection is equals to highest survival. Late detection is equals to lowest survival. For example, early breast cancer is equals to 90% survival. Late breast cancer is equals to 30% survival. So technology is biggest job in early detection. And first one is AI powered mammography. AI reads mammography with 10x more accuracy and sees pattern visible to human eye. Second one is liquid biopsy, a single blood test that detects tumor DNA. It detects cancer before symptoms, before imagining, before the tumor grows large. Smart wearable, which detects abnormal heart patterns, oxygen changes, long-term body temperatures, stress markers. This can indicate cancer risky early. And fourth one is 3D imaging and PET and CT. Modern scanners create detailed and layered images showing tumor activity, not just structure. Early detections also saves millions of lives. The key technologies are computer-aided diagnosis and AI-based screening, liquid biopsy, thermal imaging, and optical spectroscopy and smart sensors. Why it is important? Early detection increases survival rate by 30 to 80% depending on the cancer growth. Imagining technologies that changed everything. Cancer imaging is now more advanced than ever. MRI, magnetic resonance imaging, shows extremely detailed and soft tissues images, useful for brain, liver, and spinal cancers. CT scans reconstruct 3D imaging images of organ with seconds. PT scans shows metabolic activities, areas like cancer which is hungry. AI super resolution imaging. AI enhances blurry medical images into crispy clear images. Example, in 2020, Google showed an AI modeling that identified breast cancer more accurately than radiologists. It reduces false positives by 5.7% and false negatives by 9.7%. This means AI literally catches cancer humans sometimes and misses. AI can detect microtumors invisible to humans and analyze thousands of scans per minute and reduces diagnostic errors and predicts cancer type using image patterns. For example, AI for lung cancer nodules detection, AI for breast cancer mammogram analysis, AI predicts recurrence risks. How AI and machine learning predicts AI cancer behavior. AI analyzes medical history, scans DNA, lifestyle, blood markers, and tumor growth patterns. From this, it predicts which treatment will work, which drug will fail, whether cancer will return, how fast it will spread, which genes can cause the growth. Example, AI models like DeepMind's AlphaFold predicts protein structures. This protein structure helps researchers to design drugs precisely for cancer cells. Another example, in India, AI models for oral cancer screening have achieved 94% accuracy, helping detect cancer early in the rural areas. Applications, lung cancer nodule detection, breast cancer screening, AI detects microcalcifications, skin cancer detect using deep learning, pathology side implementations, chatbots for symptoms reporting. AI tools process thousands of images per second, spotting patterns, machine learning models, personal treatment by analyzing patient's history and genetics and tumor features. Robotics in cancer treatment. Robotic system in DA-Vancic surgical robot allows high precision surgery, smaller cuts, fewer complications, faster recovery, less pain. Perfect for delicate areas like prostate cancers, throat cancer, uterine cancer, lung tumors. Robots can even operate in areas where human hands cannot reach. Augmented reality in surgery. Surgeons wear AI glasses showing 3D tumor boundaries, blood vessels locations, and risk zones, which reduces surgical material drastically in when operating the human body. Nanotechnology. Nanodrugs target cancer cells directly. Nanoparticles used for imaging and hypothermia heat therapy. And also smart nano carries delivery of drugs only to tumors. 3D printing used to create tumor modeling. Patient specifically implants after cancer surgery helps doctor to practice complex surgeries in advance. Digital health, wearable telemedicine and big data. Wearable devices track patient vital during treatment like heart rate, oxygen levels and temperatures. Tele-oncology. It remotes consultations and online pathology reviews. Big data and cloud computing. It predicts the treatment outcomes and analyzes the millions of patient records and helps the researchers to find new drugs target and tracks the recurrence of risk using algorithms. Thousands of hospitals generates medical data. Cloud computing stores and analyzes this data. Big data helps to predict cancer patterns, identify risk groups, discover new medicines, track the global cancer trends, and reduce diagnosis time. Platforms like IBM Watson for oncology even suggest treatment based on millions of cases. Future technologies. The future of cancer treatment is more exciting. CRISPR gene editing. Scientists can cut out and mutate cancer genes and repair them. Nanorobots. Microscopic robots that can swim through the bloodstream, which can detect cancer and deliver the drugs and repair the tissues. Quantum computing can simulate cancer cells biology in seconds will exceed the drug discovery dramatically. Conclusion. Technology has changed cancer treatment from guesswork to precision and painful to minimally invasive, from generic to personalized, late detection to early prediction. One day, with these technologies, cancer might become a fully curable disease. In future, it is found in data centers, research labs, robotics systems, and AI algorithms. Technology is not just improving cancer treatments; it is defining hope. Thank you.